All right, we're back in the lab, and this is after a couple of days after we did the last reaction, and we have let the triphenylmethanol that we made, we have let it air out, and all of the solvent is evaporated, the material is dry. We're going to do a couple of things today. We're going to do our characterization today. So the first thing that we're going to do is get our final mass on the triphenylmethanol. That way we can tell what our percent yield was over the reaction. We're going to do a recrystallization. And then after we do that recrystallization, we'll do a melting point and determine the melting point of the material. And we'll also do FTIR, infrared spectroscopy, in order to make sure that the material is what we think it is. So that's our plan. I'll see you over at the balance to get that final weight. All right, we're over here at the balance, and we've got our triphenylmethanol. I'm going to see if I can show you what this material is looking like at this point. It's in the exact same petri dish where we left it. The petri dish does not close tightly, so vapors can go in and out, and as the petroleum ether that we triturated this with evaporates, it's released out through the container. So we should have a nice dry weight now, and we're going to take a look and see what that final mass is. .87610. Okay, the next step in our procedure calls for a recrystallization. So we're going to recrystallize the triphenylmethanol that we've got here that was done being triturated. And in order to recrystallize it, we're going to transfer, not all of it, but some of it, we're going to transfer into an Erlenmeyer flask. The Erlenmeyer flask is going to be our recrystallization glassware. We'll put solvent into a beaker. We've got our beaker labeled. We have some boiling stones that we will place in there because solvents don't like to boil in glassware very well, and the boiling stones are going to effectively provide small nucleation sites to be able to see the boiling, so our solvent doesn't get superheated or overheated. We've got our 2-propanol, we've got some pipettes that we're going to use, and the first thing that we need to do is we need to get some of this triphenylmethanol into our flask in order to be able to recrystallize. However, to do that, we want to be sure that we weigh that triphenylmethanol that we're going to recrystallize prior to doing the recrystallization so that we can tell how good our recrystallization is, what our percent recovery is on our recrystallization. So we're going to take one more trip over to the balance. We're not going to use all of our triphenylmethanol. We're just going to use a portion of it in case we make a mistake or something happens, we have more to recrystallize. If you don't have to, you never really want to commit all of your material to a step, so it's good to retain some. So we'll go weigh out a portion of this, we'll come back, we'll set up to do this recrystallization. We'll show you how it all works. All right, we're back here at the balance, and we are going to weigh out some of this triphenylmethanol for recrystallization. So I'm going to prepare some weighing paper. We'll get that tiered. With that tiered, we will then weigh out a portion of our triphenylmethanol. About 1/2 gram. We'll get the final mass on this. 0.52062. Let's get that recorded. And then to transfer that into our Erlenmeyer flask, we're going to use that weighing paper to make a small sort of funnel. And this is the reason that we really fold it corner to corner, because when you fold it corner to corner like this, the corner slides in, I'm going to see if I can show it on camera, slides in very nicely, and then just a couple little taps, and everything just goes directly in. If you need to, you can use the spatula to just police that last bit, but they're really, when the material is nice and dry, it just slides right in. Okay, let's take that over and we'll go do our recrystallization. All right, we're going to do the recrystallization now. And in order to do the recrystallization, we need some 2-propanol. And the amount that we're going to need is probably not more than a couple of mils, but because I'm going to have to heat this up and boil it, what I'm going to do is I'm just going to transfer about 10 mils, maybe 15, and I'm just pouring it down the pipette, using the pipette to help assist in pouring so I don't lose any. Uses the surface tension of the liquid to travel down the pipette. Just a nifty little trick. That should give me plenty of 2-propanol. And then I'm going to throw a couple of these boiling stones, which are an inert material that will not dissolve into my 2-propanol. I'll set that directly on the hot plate, and we will heat that up. And I'm going to set the hot plate pretty high. I'm going to set it at about 50% power while I'm getting ready some other things, because I want this to boil fairly quickly. I don't want this to take forever. But I'm going to keep an eye on it, and if it does start boiling, I'll back that temperature off really quick. We'll talk about that in a second. Okay, now, we do a recrystallization in an Erlenmeyer flask because of the shape of the flask. It's got a wide bottom for heating, very stable, a narrow top to prevent evaporation of the solvent as I'm adding the solvent to it. So all of that aids and assists in making this a good vessel in order to do recrystallizations. But they get a little hard to hold on to as they get hot. And so what I'm going to do is I'm just going to make a little collar out of some paper towels. I'm just folding up a little piece of paper towel in order to make a little band that I am then going to put around the top and give it a little twist. And now I've got a little twist tie to be able to hang on to it so that it doesn't get too hot in my hand. Now, I know that you guys haven't done recrystallizations before because you didn't get to do first semester of OChem. So we're going to talk about how we do this recrystallization. First thing is, we never just want to put this down on the hot plate without any solvent in it. The potential for melting the solid is high. And if I melt the solid which melts does not like to then dissolve into the boiling solvent to recrystallize very well. So I always want to wet this with a little solvent before I do anything else. Now, we're starting to get to boiling here, so I'm going to back off on my temperature, and I'm going to move this over to a corner where it's going to be cooler and not overboil. Then what I'm going to do is I'm going to take about a mil, maybe half, transfer it into my flask that I'm going to do the recrystallization in, set that down, and let that come to boil. Now, as that comes to boiling, this part happens fairly quickly. What we do is we give it a little bit of agitation and then fairly quick transfers, about a half mil every 10 seconds, until we just dissolve everything at the boiling point of the solvent. So everything needs to be kept hot. If you get some frothing, you can take it off and see where you're at. I still have some solid. I'm going to give it another half mil. Let that come to boiling, give it a little swirl. If you get frothing, take it off, see where you're at. There's still a little bit of solid, another half mil. All the while keeping everything at the boiling point of the solvent. Almost there. That's going to do it. So I'm going to let it boil for just a second more. I'll set this guy down. Let's take this off. All right, I'm going to reset the camera. We'll do a time lapse, and I'll show you what this looks like. All right. Cut the music. I have to explain something. So I did that time lapse, and when you're working with a cell phone in the application that I'm using, Filmic Pro, and you're doing filming like this and you do a time lapse, the time lapse setting gets stuck in the phone, and it doesn't reset unless you reset it. So I didn't reset it, which means that everything I shot from this point on was in time lapse mode. So it's kind of a bummer. It's half a day lost. Or we could look at it this way: it was a huge learning lesson. I won't make that mistake again. Well, I probably will, but I won't admit to it when I do it, so that's okay. So what we're going to do is we're going to watch some of the time-lapse footage, which is great because you'll see me doing things a lot faster. This video is going to be over quick. But we'll finish out the recrystallization, we'll finish out the filtration, we'll get the masks, the weights, I'll put them up on the screen. And then when I switch back into the instrument room and we start looking at doing the infrared spectroscopy, that part, because I reset the camera at that point, that part gets filmed regularly. So we're going to watch me in fast forward mode here for a little bit. We'll get a good laugh out of it. And unfortunately too, I missed the melting points, because the melting points, I had this whole thing. I did 2 cameras. You would have been so proud of me. It was awesome. I had 2 cameras, dual screens, and one of them I took the melting point, and the other one I took the temperatures, and I was going to sync them up on a dual screen and give it to you so you could actually watch the melting point and get the temperature at the same time. Another day. We'll see it another day. What we're going to do is we'll watch the melting points fast forward, and I'll do a voiceover on it, and we'll talk about what's going on as you're watching it. Okay, back to the regularly scheduled programming. Okay, we're in the instrument room, and we're going to try and do a little video now on how we do a solid potassium bromide prep. Now, potassium bromide comes in pellets, or at least we buy it in pellets. These are cutoffs from making potassium bromide plates that they use. They come in pretty big crystals. What we're going to do is we're going to take one of these larger crystals. We're going to give it a couple of whacks in order to fragment it into a few pieces. The pieces that we are not going to use, we will put back. I think that ought to be enough. We're going to take and we're going to grind that material up until it is like talcum powder. So the process just starts by just giving it a few whacks, giving it a little bit of pressure, trying to smash all the big pieces, and it just progressively gets smaller and finer. Let's see if I can give you an idea of kind of what we're looking at here, what that material looks like. All right, so we're going to grind that up really fine. Takes a minute, a little circular motion and pressure. And the idea here is that we want as fine a powder as we can make. Any granules that are too large will interfere with making of the pellet that we're going to make. And this is a method of IR where we embed our material in this matrix. Potassium bromide does not absorb in the infrared wavelength. That's why it's a perfect medium to be able to use to do this. And once it's ground, then we are going to apply a little bit of our triphenylmethanol that we recrystallized into this. We want about a 1% solution, so it doesn't take very much. It might even be more than I want, so I'm going to take a part of that. I'll tap it in there. And the rest that I don't want, I'll put back. And then that gets dispersed and ground. And we want this evenly dispersed, so we work on this for another minute here. Working it all down the sides and then around in circles. Just trying to make sure that it's all evenly distributed. Okay, now that it's all evenly distributed, we need to make a pellet out of it. To make a pellet, we are going to weigh out 0.20 grams of this material. I have a balance that's all set up here and ready to go. So we'll bring this in and we will grab our spatula and weigh out approximately 0.2 grams. Doesn't have to be dead on, just close. Oh, that's a little farther off than I want. There we go, that'll be good. Okay, from there, we're going to press that into a pellet. So the way that we press it into a pellet is we use this die set. And the die set is designed, this is the body, we take the body, we snap the body together. Once the body is snapped together, we take one of the anvils, we put the anvil inside. With the anvil inside, we take our powder and put our powder on top of the anvil. We flatten that powder out using a piece that's called a ram. We put it in and twist it to smooth the powder out and flatten it out. Let's try that one more time. I didn't like the way it popped up on me. All right, smooth it, flatten it out. Pull it out a little slower. The next anvil goes in with its polished side down so that the pellet is being created between the two polished sides. The anvil then goes, or the ram then goes in on top of the anvils, and then this goes in a giant press. Let's see if I can show you that press. Okay, here's the press. The body goes inside here. Once that goes inside, we have a protective shield that goes over the front, hydraulic lock. You can see the pressure that we're applying here. On the outside of this ring it says tons on RAM. We take it up to 10 tons. So this is 10 tons applied onto that piece that is now pressing that powder, fusing it back into a pellet. We let it sit there for about 30 seconds. When it's done, we release the pressure. With the pressure released, we take the body out, flip it in upside down, take a little collar, place a collar on it. The collar will help, I'm going to hold it in place while I do this, so that the thing doesn't fall apart. We knock the pellet out of the center. I'm going to capture the pellet and see if I can show you what this pellet looks like. So the pellet is between the two pieces that we call the anvils. We'll take one off, and there is the pellet. And you can see how small, how thin, and how clear that pellet is. We're going to take that, put that in the instrument, and get our IR.